Hey, what's up everybody? My name is Coach Anderson, and in this video, we're gonna talk about how you can classify different types of matter. Now, the first thing that you need to know is that matter is anything that has mass and takes up space. Let's go ahead and get started by looking at the different types of matter. So again, matter is all around us. Matter is anything that has mass and takes up space. For instance, the planets in our universe are made up of matter, and all the random objects around you are also made of matter. For instance, a basketball. A basketball is made up of matter. It has mass and it takes up space. Now, we can classify matter into different categories. In this video, we'll talk about pure substances and mixtures. We'll dive deeper into elements and compounds and homogeneous and heterogeneous mixtures. Let's first look at pure substances. All right, let's go ahead and talk about pure substances. Now, a pure substance has a definite composition. The two types of pure substances that we'll look at in this class are elements and compounds. Now, you've probably heard these words before, but let's go ahead and review them. An element is a pure substance made up of only one type of atom, and it cannot be broken down into a simpler substance. A good example is any element on the periodic table of elements, things like carbon, hydrogen, oxygen. These elements have a chemical symbol. For instance, I have a block of copper here. Its chemical symbol is Cu. Now, copper is an element. It cannot be broken down any further, all right? Copper is an element. An element is one type of atom that cannot be broken down any further. On the other hand, we have compounds. Now, a compound is two or more elements chemically combined. A good example you might know is water, or H2O. This is two hydrogen atoms with one oxygen atom, all right? The hydrogen and oxygen bond together, they chemically combine, and they form a compound. That's water. Another compound you might know is NaCl, or table salt. This is sodium and chlorine bonded together. Okay? Now, to differentiate between elements and compounds by looking at them, we can see that an element is symbolized by a chemical symbol, and a compound is written as a chemical formula. Elements have one capital letter, and compounds have two or more capital letters, all right? So that's elements and compounds, which are pure substances. Now we can look at mixtures. Okay, next let's talk about mixtures. Now, mixtures are made up of different substances. It could be elements and compounds together, but they're not chemically combined, okay? Mixtures have a variable composition. There's two types of mixtures: homogeneous or homogeneous mixtures and heterogeneous mixtures. Now, if you think back to 6th grade, we talked about how mixtures can be separated using physical properties, things like color, size, density, magnetism. For instance, if we mix a bowl of cereal and milk, the cereal pieces will float to the top because they're less dense than the milk. Or if you have cereal that's fortified with iron, you could crush it up and use a magnet to draw out the little pieces of iron and separate the iron from the cereal, okay? Now let's talk about the two types of mixtures. We have homogeneous or homogeneous mixtures first. Now, homogeneous mixtures look the same throughout. That prefix homo means same. Things like salt water or coffee, right? If I were to mix coffee and sugar in this cup and drink it, all right, that would be a homogeneous mixture. It looks the same throughout. Another good example might be lemonade, all right? If you look at this bottle, it looks the same throughout. It is uniform in appearance. Now think about it. If you and I were wearing a uniform, we would be dressed the same. So homogeneous mixtures look the same and they are uniform in appearance. Now, on the other hand, we have heterogeneous mixtures. Now, that prefix hetero means different, okay? Heterogeneous mixtures can easily be separated. It's more difficult to separate homogeneous mixtures, but heterogeneous mixtures we can easily separate, all right? There's a bunch of different parts. For example, you might have a salad. A salad is a heterogeneous mixture, all right? It is not uniform in appearance. There's a bunch of different pieces. It looks different. We could pull out the lettuce and the tomatoes and the cucumbers and the cheese. Another good example might be trail mix, all right? If you have trail mix, there's almonds and peanuts and candy and raisins, all right? You can easily separate the different pieces, okay? So to recap, we have homogeneous or homogeneous mixtures, which are also called solutions, and we have heterogeneous mixtures. Homogeneous mixtures look the same throughout. They're uniform in appearance. And heterogeneous mixtures look different throughout. They are not uniform in appearance, okay? So that's all I need to know about mixtures. Let's go ahead and move on. Now that's definitely a lot of information, I know, but let's go ahead and take a look at this flow chart, okay? Now if you look at this little chart, you can see that we have matter up at the very top, and matter can be broken up into pure substances and mixtures. On the pure substance side, we have elements and compounds. Remember, an element is made up of one type of atom and cannot be broken down into a simpler substance, and a compound is two or more elements chemically combined. Then we look at the other side and we have mixtures. All right, we have two types of mixtures, homogeneous mixtures and heterogeneous mixtures. Our homogeneous mixtures look the same throughout, they're uniform in composition. Our heterogeneous mixtures look different throughout, and they are non-uniform in composition, okay? This is how you can classify matter. All right, thank you so much for tuning in today. I hope you learned something new. Remember to be kind to one another, make good choices, and I look forward to seeing you in class.